Okay, so this first question, and please tell me if my sound goes bad again, please. The first question says, find the value of two numbers if their sum is 12 and their difference is 4. What does sum mean?
When you add
Sum mean?
Adding, good, somebody said adding. What about difference?
Subtraction?
Subtraction. Okay, guys, please don't just start taking numbers and trying to figure this out. We're gonna put together an equation. What are my two variables that I'm going to use for this question?
Addition and subtraction?
Yeah, I'm gonna have an equation of addition and an equation of subtraction, but what variables do you want to use? Find the value of two numbers. What variable should we use for those two numbers?
M and X?
Sure. You can pick anything. Just tell me what they mean. So Matthew, you said M and X?
Yeah.
Okay. So M is the first number. X is the second number.
Yeah.
Okay, how do I put together an equation that shows when I add M and X, their sum is 12?
You could put, well, if you have to use a subtraction and addition sign, you could put M plus a negative number could equal 12.
So the sum, Matthew, is going to be one equation. The difference is going to be a second equation. So go
Okay,
for
yeah.
a second.
Okay, yeah.
If I'm going to add them and their total is 12, what will that look like?
Will be M plus X.
Yes, equals?
It's 12.
Awesome.
I thought you had to put both. I thought you had to put a subtraction and an addition sign into the equation.
No, so we're always going to make two equations because we are creating a linear system. How do I show that the difference between M and X is 4?
Well, you could do M subtract X equals 4.
Exactly. Now we have to make a choice. Substitution or elimination?
Elimination.
Okay, I would agree. Now you could do substitution. However, one of our variables already has the same coefficient and opposite signs.
Yeah, that's X.
X.
So you could just take away X and you could do M plus M will be, or you will use the top, or can we just go, okay, if we, so we'd have to pick one of the top row, or top or bottom row, right?
What do you mean pick it?
Well, like, can we just throw all these numbers into one line?
Yes.
Okay, so then can we do, well, M plus M would be 2M equals 16. And then you divide 2M by 2, you divide 16 by 2, and it'll be M equals 8.
Very good. I can't change my number or my colors.
I don't know how
Okay, one of the numbers that we're looking for is 8. How do we find our second number?
Well, since we need to find what X is, we could use, okay, so then we could plug X into the bottom row. So we could do,
Yep.
So we could do X subtract X equals 4. Or M subtract X equals 4. And I'd plug in for 8. So then, and then you'd have to put 8 on the other side so that would become negative. So it'll be negative X equals 4 subtract 8. I can't see, one second, I can't see the side of the screen. Okay, there. And then you're gonna put, you're gonna divide -1 by well, you divide negative X with negative X, it'll be -1, it'll be -3.
No, it's division. -4 divided by -1.
Oh, sorry. And then
What's negative divided by
it's -5. It's -5. Sorry.
It's actually going to end up being +4.
Wait, what? Oh, I did subtraction. Yeah, okay.
Okay, we don't want to write this at the point of intersection. We just want to write a therefore statement.
So
So
therefore, the linear equation would be 8 m would it should be 8 dash 4.
well, actually, go back to, that's true if we wrote it as a point. Go back to what we were looking for, though. We were looking for two numbers, right?
8 m, yeah, we were looking for 8 and 4. Oh, so the okay, one sec, I can't see the quick. The value the difference. Wait, find the value. So the value of the two numbers are 8 and 4.
Yes. Okay. Now, some of you guys were maybe just trying to randomly find those two numbers, but 8 plus 4 is 12, and 8 take away 4 is 4. So it fits the qualifications, but the numbers are not always whole numbers. So please don't just try to guess and check. You could be guessing and checking your whole life. So set up a linear system. This involved reading the question, interpreting it, making equations, and solving. Any questions on that one? Okay, let's look at this one. Matthew, I appreciate that you answered that one. I'm going to ask somebody else to try to talk us through this one. And I can't change. Oh, let me try this. Okay. A boat traveled 336 miles downstream and back. The trip downstream took 12 hours. The trip back took 14 hours. What is the speed of the boat in still water, and what's the speed of the current?
Can I do it?
No, well, I'm going to ask somebody else, Matthew. Does anybody know the equation for speed?
Can I say it?
Mass times acceleration.
Mass times acceleration is force, Zach. So think about your speedometer on the car. What does our speed look like?
Kilometers?
Kilometers per
hour.
So how do we figure out speed?
Miles divided by time.
Yeah, so it's your distance divided by time. Okay, so that's part of this. I will not make it a layered, complex question like this for your test, but this is assuming that you guys have learned the formula for speed at some point in the past. So we do have to figure out the speed downstream and the speed upstream. So let's just quickly do that. And I'm gonna ask you guys, hopefully you guys have calculators or some form of being able to, I'd rather not use your phones, but if you have to, pull it out. The speed.
336 divided by 12 is 28.
Thank you, Zach. And that was downstream, right?
Yeah.
Tell me one more time, Zach. 28?
28, yeah.
And what about back? So this would be upstream. What's the speed?
That would be 24 miles an hour.
Okay, now that actually was a little bit of just pre-work. Unfortunately, we had to do that here. Okay, we're trying to find the speed of the boat and the speed of the current. What variables should we use?
Could you just average it out and say 26 miles an hour is the speed of the boat in still water?
Well, Zach, let's see if that assumption works. Let's try to solve this with a linear system. We'll see if that works here. I'm going to use B for boat and C for current, if that's okay with you guys. And I can think about this a little bit easier. Okay. If you were going downstream, what happens to the speed of the boat if it's going with the current?
It's going faster.
Faster. Do you think I'm adding the speed of the boat with the speed of the current, or am I subtracting? Will those speeds be added? Are those two vectors going in the same direction, so adding, or are they going against each other, so subtraction?
Adding.
Thank you, Mia. Adding. When the boat is traveling with the current, it's adding it. They're going in the same direction. Now, what happens when it goes against the current?
It's subtracting.
Good, Logan. Subtraction. The boat speed would be going opposite to the current speed. Okay, do you want substitution or elimination?
Elimination.
Okay, and what are we gonna eliminate? B or C?
C.
C.
C. I think Logan said C and somebody else said B. You could try B. They don't have opposite signs, so we'd have to do some switching, but C already has opposite signs. So I can immediately add the opposite. Logan, I think you told me to do that. You want to keep going with this question? When you add them, what do you get?
Wait, I can barely hear you.
Oh, sorry. I'm moving closer to my computer again. Logan, I think you told me to get rid of the C. Do you want to tell me what I have now
Yeah.
when you add them?
2B and then 28 plus 24, which is 52, I believe. And then divide by 2, which is
Zach, I think
26.
Zach's initial thought here was good. So the boat speed is 26 miles an hour. What does that make the speed of the current? Boat speed is 26. What does that make the speed of the current?
2.
2. Exactly. So you can plug it into either equation and solve, but it does make the speed of the current to be 2.
Wait, where'd you get 2 from?
Here, I'm going to do it, Matthew.
Oh, did you divide? You divided 52 by 2, and then you divided 2b. I get that, but where did you get what's it called? Wait, where? Oh no, okay, never mind. Oh, 20. Oh, it's 28 subtracted by 20. Okay.
There you go. All right, my therefore statement, that is just therefore the speed of the boat is 26 miles an hour, the speed of the current is 2 miles an hour. Okay, if I give you one like that as an option, I will actually make sure that I give you the speed already, and you will not have to do that first calculation. This one was just written a little bit tricky. Any questions on this one?
Will that be on the chapter test?
So you'll have a variety of different types of word problems, Matthew, on the chapter test, and I actually just have you choose 2 of 5 or something like that.
So you'll give us the options?
Yes.
How much would these be worth 5 marks?
This one is
7?
no. Hold on, I gotta think a second, because I there's a mark for like defining your variables, setting up the
Yeah,
equation.
no, that's what because you have to do
So-
therefore statement is 1 mark, and then you have.
Yeah. So I would say
So-
you're probably right, probably about 5.
All right, thank you.
Yeah. Okay, I think we just have one last one here. The state fair is a popular field trip destination when it's not COVID. This year, the senior class at high school A and the senior class at high school B both planned trips there. Senior class A rented and filled 8 vans and 8 buses for a total of 240 students. B rented and filled 4 vans and 1 bus for a total of 54 students. Every van had the same number of students in it as well as the buses. Find the number of students in each van and in each bus. Suggestions. Let's start with defining variables. What are we trying to solve for?
Can I say it?
Yes, Matthew, go ahead.
Okay, so wait a sec. I have to read it again. Let's see. Okay, so one of the variables would be A and B. Well, yeah, we could use A and B, right? Because if you have you have the A high school. Oh, sorry, one sec. You have high school A, and then you have high school B, and then high school rented filled 8 vans and 8 buses with 240 students.
Yeah,
So you'd have to
what are we
so
solving? What are we solving for though?
find the number of students. Oh, okay, in each van in each van and each bus. Okay, so you'd have to put 2. You have to put 2. You'd have to do 2 lines, right? Or 2.
Yep.
Okay, so the first one you could put.
Matthew, can I suggest we use V for van and B for bus before we put together our equations?
Okay.
Okay,
So
let me write that down.
So the first van, so it'd be B. It'd be B, and okay. So then so 8 vans and 8 buses. Okay, so you have 8 V plus 8 B equals 240. And then that's for cohort, or that's for the not cohort, that's for high school A.
Yep.
And so then can we solve it from here?
No, we need a second equation.
Okay, the second equation will be it'll be 4V 1B with and equals 54.
Substitution or elimination?
Substitution.
We're gonna do this. I like that. We're gonna try this. I was thinking we haven't done it yet, so let's do that. What variable is positive with a coefficient of 1?
B.
Yes. Okay,
So we could, if we change, can we change okay, never mind. So you can move 4V to negative 4V. So it'll be 1B equals 54 subtract 4V. And then from there, you're going to want to subtract it. So it'll be 50V. So B equals.
That's why I actually can't simplify that. They're not like terms.
Oh, yeah. Sorry. Yeah.
What am I going to do with 54 take away 4V? I'm substituting it in for what?
You're substituting in for 1.
Which variable did I just isolate for?
B.
Yep, so I'm going to substitute in for B in the blue equation.
Oh, so you're substituting 8B. Right?
What does that look like?
So you'll put 54 in for 8B, and then you'll bring 8B over to.
Right.
Yeah.
Okay.
Yeah, and then what you're gonna do, you're gonna do brackets first. So you do 8 times 54, which is 8 times 54 is 432. And then you'll do 8 subtract 4V, which will be 4V.
What's 8 times negative 4V?
Oh, sorry, 8 times, yeah, for 8 times negative 4. It would be negative 32. And then you'll want to find, so there's the 2 variables, so you'll want to subtract 8V from 32V.
Mm-hmm.
So you'll get.
Do 8 take away 32?
8 take away 32
Yeah.
will be 24. Negative 24, sorry. And then you'll do, and then, wait, no, we haven't done 432 yet.
Right.
So you'll put, or you could just move it over. You don't even have to do that. You could just move 400, you could do equals 240 subtract 432. Which would be negative 192. And then you're gonna want to divide, so you'll divide negative 192 by negative 24, which is gonna be negative 8.
Okay,
Or positive 8. Sorry, positive 8.
Good. Okay. So you just found that the vans can hold 8 people each. Now we need to figure out how many people can go on the bus. I'm going to go back to our first two equations. Which one, the red one or the blue one, would be easier to solve for the number on the bus?
The top one, because there's already 8 in the bus, or 8 in the van.
Well, that 8 actually is just a coefficient to be taken into account. Matthew, if you look at the red one, 1b is just b, so it's already isolated, right? And look at what you did here with the isolation. B equals 54 take away 4b.
Oh, yeah. Sorry. So then you could, yeah. Okay, I was thinking that since there's already, the answer was 8v, you could just put in, what's it called? You could just put in like that. But anyways.
So it's 54 take away 4 times 8.
54 take away 4 times 8.
Yep.
Is 22.
Good. So what's our therefore statement?
Therefore, buses could hold 22 kids and vans could hold 8.
Nice. I guess I should have checked our answers on each of these, but I could go and check 8 times 8 plus 8 times 22 and make sure that equals the 240 to make sure that we've done it correctly. Any questions on that one?
8 plus 8 times 22?
8 times 8 plus 8 times 22.
Yeah, it's 240.
Yeah, awesome. So I missed that step. Make sure you guys always check your answers. You should walk away extremely confident that you've done this whole chapter test, right? Because you can literally check all of your answers. Just plug them back in. Okay?